This is valence electrons in the periodic table, and we deal with valence electrons almost exclusively in chemistry and biology because valence electrons are outermost level electrons, and those are the electrons that are involved in chemical bonding, which we work with ionic and covalent bonds. So just some things to be critically aware of. Our first shell can hold up to 2 electrons. Our second shell can hold up to 8 electrons, and our third shell can also hold up to 8 electrons at this foundational level. Electron-filling shells correspond with the periodic table. So if you look at the periodic table, you'll notice the first period has 2 elements in it, and that represents the first shell up to 2 electrons. So if an atom has 1 electron in it, it would be 1 proton and 1 electron, it would be hydrogen. If it has 2 protons and 2 electrons, it would be helium. From there, we have to go down and start filling up the second shell. Second shell has up to 8 electrons. Notice in the second period, there are 1, 2, 3, 4, 5, 6, 7, 8 elements. And in the third period, also up to 8 electrons, there are 1, 2, 3, 4, 5, 6, 7, 8 elements. So the periodic table really is just built off this electron shell filling theory. It gets a little more complex when you get to the fourth and fifth periods, but we'll deal with that later on in our course. So if we're going to represent inner electrons as blue and outer electrons as red, if we go to lithium, we have an atomic number of 3. So we're going to have 3 protons, and if it's a neutral atom, we're going to have 3 electrons. So to draw our lithium, we're going to put 3 P pluses, or 3 protons, in the middle. In our first shell, we're going to put 2 electrons. And in our second shell, we're going to put 1 electron. So there is lithium with its 1 red valence electron. Our valence electrons here are going to be represented by the red dots. And that corresponds with the periodic table, because notice lithium is in the second row and the first group, meaning it has 1 valence electron. If we were going to go to beryllium, it would have 2 valence electrons. Not surprising now, next we're going to do carbon, and we're going to walk across that second period and that second shell, and we're going to end up with 1, 2, 3, 4 valence electrons, which is why there's this Roman numeral 4 on top of this row. So carbon has its 6 total electrons and 6 protons. So here we go. We have 6 P positives in the middle. I'm just going to go all red and all blue. In our inner shell, we have 2 electrons. And in our outer shell, to get up to 6, we're going to add our third, fourth, fifth, and 6th electrons. So as predicted, notice that carbon has 4 valence electrons. Fluorine is 3 away from carbon. Notice it's in group 17 here. So it's not, if carbon had 4 valence electrons, everything in nitrogen would have 5, oxygen 6, and fluorine 7. So fluorine has a total of 9 protons, and we're kind of predicting here that it's got 7 valence electrons. Let's see what happens. So fluorine with its 9 protons in the nucleus. First shell has 2 electrons. And we've got to get up to 9 total, so we're going to put 2, we have 2 already, so 9 minus 2 is 7, so we need 7 more electrons. 1, 2, 3, 4, 5, 6, 7. So there's a stable atom of fluorine in the second period of the periodic table with 7 valence electrons. The nice thing about the periodic table, if you know the valence electrons in period 2, you know everything underneath them as well, because the periodic table follows patterns. So we did lithium, and lithium had 1 valence electron. It was in group 1. Not surprisingly, sodium is in the same group on the periodic table. It's also going to have 1 valence electron. Check it out. So sodium in general, a neutral atom of sodium, has 11 protons. You might want to walk through the periodic table with this, your own periodic table, as you look at this. So here's our 11 protons in the middle. The first shell has 2 electrons, and there they are. The second shell, we've got to get to 11. The second shell can hold up to 8, so we're going to use all 8. 1, 2, 3, 4, 5, 6, 7, 8, and that's the second. I did those blue because those are still inner level electrons. Those are not valence. So now I have 2 plus 8. I have 10 total electrons. I need 1 more. So here's the 11th electron in the third shell. I'm going to stop right there. I'm not going to draw the whole thing. And that corresponds with sodium being in the third period on the periodic table and in the first group. So if we know, because we know the electron configurations or the valence electron sets for the elements in period 2, we can accurately predict anything below that. Notice lithium has 1 valence electron. Sodium, right below it on the periodic table, 1 valence electron. We're not going to draw it out, but we could predict that elements like potassium, rubidium, and cesium also have 1 valence electron, and that's critical. We'll go right below carbon, and we'll go to silicon. And so the prediction would be that silicon is going to have 4 valence electrons just like carbon. Let's see what happens. So silicon's atomic number is 14. So it's got 14 protons in the nucleus. I'll go a little bit quicker this time. So first shell, 2 inner electrons. Second shell, 8. 1, 2, 3, 4, 5, 6, 7, 8 in the second shell. So that gets us to 10 electrons. We have 4 more to do, and not surprisingly, we're going to put 4 electrons in the third energy level. Should have spaced those out a little better, but for the sake of notes, that's going to be all right. So notice that carbon had 4 valence electrons. It's in group 4A on the periodic table. Silicon directly below that also has 4 valence electrons. We'll do one more with chlorine. Should be getting kind of redundant now. Fluorine directly above it had 7 valence electrons. So chlorine's also going to have 7 valence electrons, most likely. Here we go. So chlorine has 17 protons. I'm just going to draw the 2 shells, first shell, second shell, and we know we're going to use the third shell also. So 2 electrons in the first shell, 8 electrons in the second, 2, 3, 4, 5, 6, 7, 8. 2 plus 8 is 10. Chlorine has 17, so we need 7 more electrons. 1, 2, 3, 4, 5, 6, and 7. So again, folks, the periodic table is just that. It has periodic properties. It's built on these electron patterns. Once you know the valence electrons for a group 2 element, you pretty much know the valence electrons for anything directly below it on the periodic table.